Sealed classes. Sealed classes are really enums on steroids. Now, why should you use them? Well, similar to enums, they make your code safer, easier to maintain, and they leverage the power of the compiler, meaning that rather than an end user seeing some bug that you missed, the compiler will warn you straight away and you're able to fix it.
Just fix me.
But the difference, though, compared to enums, is that sealed classes do more. They can do things that enums cannot. And that's what we want to focus on in this video. Now, if you'd like to know a bit more about enums, please check out my previous video where we explain it. But in this video, we're going to focus on the pain point, the problem that you probably have in your code that sealed classes solve. We'll see how you can practically use them. And we're going to specifically focus on real examples to help train your mind and help you to see where practically you can use sealed classes in your own code base. And so without further ado, let's get straight into it. Here's the problem that makes us need sealed classes. You see this enum, we have 4 values, and this works perfect, beautiful in most cases. But what happens when, for this loading value, we want to supply to it a progress value, maybe a number between 1 to 100. Or for this error value, we want to supply an error message so we can display this to the user. Enums cannot do that. It is a limitation of enums. Now we may be thinking, wait a second, what about enhanced enums? Enhanced enums allow us to associate or attach different values to each one of the enums. And that is true, but with 2 significant limitations. The first one is that each of these enums have the exact same structure. So all 4 of these enum values need to supply, in this case, a message and an icon. But the bigger hurdle is the fact that all of these values have to be constant values. You see, we cannot on the fly supply these values as and when we like. We need to do it at the start before our program or our application even runs. And this is the problem or the limitation with enum. Now, this is one way we might get around it, right? We have our enum set up just like before. We save that enum value somewhere. And in addition, we have 2 variables, a progress variable linked to the loading state and an error message linked to the error state. So that when we set the state to error, for example, we also will supply an error message. But let's be honest, this is messy. This is difficult to maintain. The issue is that firstly, we can have invalid combinations. So when this is set to idle, our error message could have a value, or worse yet, this could be set to error and our error message could have no value, causing our app to crash. But in addition, the issue with this is it's relying a lot on you as the developer, your brain power, because now you have to remember all these connections. You have to remember this progress variable links to the loading state. This error message links to the error state. And a third reason why this is bad is because it's not leveraging the power of the compiler. The compiler is not able to help us validate that all the states match or are linked correctly in any way. This is messy, non-maintainable code. So we might decide to do this instead. We create a class for each possible state. And for those classes that need extra data, well, we can just create it in the class. And what this means then is that when we have a variable which holds one of these possible states, you notice here that it now needs to be dynamic. And this again is an issue. It can lead to runtime errors rather than compile time errors because we can assign any value to this variable over here. It could be a string, it could be an int, it could be anything, including these classes we have created, which again means more work on you as the developer. So you might have immediately thought of the solution. Use an abstract class. So we have this abstract class called progress state as an example, and each of these different classes which represent one of our state values, each of them extends this single abstract class progress state. And what this means is that where we have our variable which holds one of these state values, instead of it being dynamic, it can now be of a type progress state, our abstract class, meaning that this can only be one of our 4 values in this case, or classes in this case. Now this is almost a perfect solution. Type safety, the intent is clear to the developer, but with one drawback. Notice the switch statement, right? We have supplied a case for each of these possible states, but you'll notice we also still need to supply a default case. And that's because the compiler does not know all the different classes which extend our progress state abstract class. Meaning that if I were to now add a new state value, for example, a warning state, it extends the progress state, but now this switch statement gives me no warning. I could easily have missed adding a case for this new warning state. The solution, you guessed it, sealed classes. Now you'll see here our structure is identical to what it was before, but instead we're just going to change one word, abstract to sealed, making this progress state now a sealed class. Now you notice what happens if we scroll down to our switch statement here. Now the compiler is letting us know, listen, we don't need this default case anymore. We can remove it. Why? Because the compiler knows all the possible states, all the possible classes that extend our sealed class progress state. You see, that's the difference between a sealed class and an abstract class. In every way, they're the same except for one. And that is that a sealed class can only be extended in the same file, or more accurately, in the same library. So for example, if I switch to another file, here you can see I've imported that other file with where we declare the sealed class, but you notice it is not letting me extend it. It gives me a warning saying the class progress state can't be extended, implemented, or mixed in outside of its library because it's a sealed class. And so that is the power of sealed classes. Rather than relying again on you as the developer to remember where you've used switch statements and make sure that you've provided cases for every possible scenario, every possible state, sealed classes guarantee, they make the compiler aware that, listen, here's all the possible combination, here's all the possible values I can have for progress state. So instead of guessing, instead of needing to try remember all these places, we're letting the compiler do the work.
That's what I'm talking about!
So let's now look at real life examples where sealed classes can be very handy. One example is to do with images, right? Maybe you want to create a widget, a screen that displays an image in full screen. The thing is, images can come from various places. They can come from a file. You could use a URL to download the file. It could be from a package such as Image Picker, which gives you a X file. And so what we could do in this case is we create a sealed class called AppImage, and then we create a class for each of those different types of images, or we should say where they come from, and extend AppImage, whether it's a file, X file, bytes, or if it's a URL or URL. And what we do, since AppImage, or I should say since sealed classes are really abstract classes under the hood, to simplify things, we can create this getBytes method that each of those different versions has to implement. That way, with one method, it doesn't matter which class has extended AppImage. With one method, we know that we can get the bytes. And so if we look at what our widget might look like, right? We have this full screen image viewer. We pass in this AppImage, the sealed class. And then in our state, you'll see we have a variable here, and we call that getBytes method on the AppImage. We save that future to a variable, and then we use a future builder. Now, if you're interested to know why we didn't take this and call this getBytes method directly here by the future builder, well, there's a very good reason. If you want to know the reason, please comment down below and I'll gladly explain it. But this is a very bad thing to do. We would not want to do this. So we go back to using the variable, we pass it here, then if it's busy loading, we show an appropriate widget. If we have no bytes, again, we show an appropriate widget. But when we get the bytes, well, then we can easily show that image, no matter where those bytes came from, no matter if it's a local file, if it's a pic file, and so forth. But because this is a sealed class, you can see we have a text widget here. And what we can do is we can provide the case for each of those different types and just apply a simple bit of text stating where this file came from. So if it's a local image, local, picked, and so forth. We don't need a default, and it will moan at us if we add a new type in the future. Here's another simple yet really useful example of using sealed classes in real-life applications. Sometimes we want to return either a value or an error message. And so we can do that by creating a sealed class called result. It will need to be generic in this case. We won't dwell too much on that though. And then we create a class that extends result called success, which accepts a value. And we create a failure class which extends result, which accepts a string, which is the error message. And so then for its use, here's an example. We have a method called fetchNumber, which all it does is returns a number between 0 and 1. But if the number is smaller than 0.3 or bigger than 0.6, well then it's a failure. And it can return, in this case, a failure with an appropriate error message. But if it's not smaller than 0.3, not bigger than 0.6, it will return the success version with that value inside it. So as using it, we have this method being called here, saved to a variable, and we can now use a switch statement. And you'll notice there's no default. There's only these two cases that need to be covered. For the case of the error, we can simply print that error message from that variable error. And in the case of a success, well, we can do whatever we want with that actual value by calling, in this case, success.value to access what the value is, in this case, a double, and we can multiply it by 100 and then simply print it. A final example we'll look at is to do with chat applications, right? Often in chat applications, you can do more than just send text messages, right? You might be able to send an image, you might be able to send a voice message. And so what we can do in this case is create a sealed class called message. And then for each of the different types of messages, well, we can create a class and extend message. So for a text message, which will accept text, an image message, which could accept a URL to get the image, and then finally a voice message, which could accept, for example, the URL for the audio and also the duration of this voice message. And then for the actual widget that would then display this, we would obviously supply that message. And again, a simple switch expression. For each of those different types of messages, we can supply the appropriate widget. For a text message, text. For an image message, we can do an image.network. And for a voice message, we could simply show a row in this example with an icon and the text of the duration. Again, no default needed. And if we ever added an additional type of message, maybe a sticker or something like that, again, the compiler would warn us. Now you may be wondering, since sealed classes can do so much more than enums, should we just use them all the time? Well, the simple answer is absolutely not. That would be like using a chainsaw to cut bread. It's overkill, it's not necessary, and it adds more code than what's necessary. So, then how do we know when to use enums versus when to use sealed classes? Well, put simply, we just need to answer two questions. Firstly, are the values involved constant values? Meaning before the app runs, do we know exactly what those values are? And secondly, is the structure for each of those values identical or very similar? If we answer yes to both those questions, then we will use an enum. But if we answer no to any of them, so if those values are not constant, meaning only while the app is running will we know what those values are, or if the structure is drastically different for each value, then we will use a sealed class. Now it's true, in life, being lazy is terrible. But when it comes to coding, being lazy is the best thing ever. The reason being because we let the compiler do the work. We want to have that lazy mentality, as it were, to shift as much work, as much checking, as much validating onto the compiler to limit human error and bugs. So here's a goal or challenge for you to take this just from theory to actually being practical and what you use in your own code. As soon as possible, I want you to go to a project you're working on or perhaps worked on in the past and try to find some piece of code that should have been a sealed class. And then I want you to refactor it. And once you're done doing that, please take your hand and give yourself a good pat on the back. It's taking it from theory to actually using it in your code. And please comment down below what the change was you made where you used sealed classes.